AI broke the internet again, and this week has been absolutely insane. Meta releases Muse Image and Muse Video, built by their new Meta Superintelligence Labs, and Muse Image is already number 2 in the world on Arena for text-to-image, single-image editing, and multi-image editing. xAI releases Grok 4.5, the most token-efficient frontier coding model right now, hitting 80 tokens per second while using 4.2 times fewer tokens than Opus 4.8 on the same tasks. Alibaba's Rabiant releases Lingbot VLA 2.0, a universal robot brain that now runs across multiple different robot bodies at 130 milliseconds per inference call on a consumer RTX 4090. NVIDIA releases Audex 2B, a 2 billion parameter model that does speech recognition, speaker diarization, text-to-speech, sound generation, and speech translation all in one. OpenMOSS releases a 0.9 billion parameter model that takes up to 90 minutes of any meeting audio and turns it into a speaker-tagged, timestamped transcript in a single pass, beating every commercial system it was tested against. OneStreamer drops version 0.2, upgrading the output resolution from 192p all the way to 640 by 368, without changing the 200 millisecond model-side latency at all. ByteDance releases Seedream 5.0 Pro, their flagship image model targeting GPT Image 2 with layer separation, precision editing, and 14-language native text rendering, priced at a fraction of the cost. And we have a new open-source interactive world model with real-time camera control and long-horizon memory consistency that generates playable video scenes at 720p and 24 FPS. And Reve drops version 2.1 of their image model, jumping 36 arena points in a single month and hitting top 3 across 6 separate categories, all from a 65-person team and a lot more. So let's jump right in. First up, Meta makes a pretty major announcement this week. It's called Muse Image and Muse Video, and these are the first media generation models from Meta Superintelligence Labs, which is Meta's new AI research division. Now, Muse Image isn't just a text-to-image model. It operates as a full agentic system. Instead of directly mapping your prompt to an image, it invokes search and coding tools, reflects on its own outputs, and can decide mid-generation to try a completely different approach if the first attempt isn't good enough. Specifically, it learned 3 agentic behaviors during training. The first is tool use. It can call a search tool to ground factual and real-time visual references, and it can write and execute code to produce accurate plots, QR codes, and rendered figures, which it then conditions on to improve the final image. The second is self-refinement. During generation, it reflects on its own work in the chain of thought and can make a targeted local edit, start over from scratch, or pivot to using a tool, depending on what's wrong. And the third is test time compute scaling. With more compute, the model reasons longer, uses more tool calls, and produces more self-refinement steps. And the quality scales log linearly with total compute, which is the same kind of scaling behavior we see in language models. Now, importantly, the self-refinement behavior was not programmed in. It emerged naturally during reinforcement learning because the model discovered that self-refining produced better images and therefore higher reward. For your reference, here are the benchmark numbers. Muse Image currently holds the number 2 spot on Arena for all 3 evaluated categories: text-to-image, single image editing, and multi-image editing, as measured by human preference ELO rankings as of July 5th. In terms of features, it supports multi-reference image composition, meaning you can combine people, objects, clothing, styles, and environments from multiple input images into one coherent output in a single prompt. And it includes something they call Content Seal, an invisible watermarking system where a hidden provenance signal is baked into every image it generates, and it stays intact even when the image is cropped, compressed, resized, or screenshotted. Muse Image is live now in the Meta AI app, on meta.ai, in Instagram Stories in the US, and in WhatsApp in limited countries. Muse Video is still a preview and is coming soon to creators and Meta AI. Now, on Arena, as of July 5th, Muse Video also ranks number 3 for text-to-video. But they're upfront that there are current gaps in audio-video synchronization and physically accurate fast motion they're still working on. If you're interested in reading further, I'll link to this page in the description below. Also, this week, xAI releases a pretty impressive new frontier model. It's called Grok 4.5, and this is their smartest model ever, built to excel at coding, agentic tasks, and knowledge work. Now, for the benchmark numbers. On Terminal Bench 2.1, Grok 4.5 scores 83.3, which puts it in a three-way tie for the top with Fable Max at 84.3 and GPT 5.5 Xi at 83.4, and above Opus 4.8 Max at 78.9. On SWE Marathon Resolution Rate, Grok 4.5 scores 29.0, ahead of Opus 4.8 Max at 26.0 and Fable Max at 24.0. On Deep SWE 1.0, it scores 62.0, behind Fable Max at 66.1 and GPT 5.5 Xi at 64.31, but ahead of Opus 4.8 at 55.75. On SWE Bench Pro Resolve Rate, it scores 64.7, behind Fable Max at 80.4 and Opus 4.8 at 69.2. Now, I'll note these are all xAI's own published numbers, and competitor figures are drawn from each model's published system cards, so there's no independent evaluator confirmation yet. Now, the most interesting number in this whole release is actually the token efficiency stat. On SWE Bench Pro, Grok 4.5 resolves tasks using an average of 15,954 output tokens. Opus 4.8 Max uses 67,020 for the same tasks. That's a 4.2 times difference. So you're paying for 4 times fewer tokens and still getting comparable results on most benchmarks. In terms of serving speed, it runs at 80 tokens per second, which is fast model speeds for a frontier quality model. Pricing is $2 per million input tokens and $6 per million output tokens. For comparison, Opus 4.8 is $5 and $25. So Grok 4.5 is less than half the input cost and a quarter the output cost of Opus, and it's using 4 times fewer tokens per task. Now, it was also trained alongside Cursor, which is the first time xAI has trained a model in collaboration with an external developer product. And it's available now in Grok Build, in Cursor, on all plans, and through the xAI API console. Note that EU availability is still pending and is expected in mid-July. If you're interested in reading further, I'll link to this page in the description below. Also, this week, Robiant from Ant Group releases a really impressive new robotics model. It's called Lingbot VLA 2.0, and this is a next-generation vision language action model designed to work as a universal brain across multiple different robot body types, not just one specific hardware platform. Now, you see, one of the biggest bottlenecks in robotics right now is that most VLA models, even the good ones, tend to work well in the lab, but struggle in deployment. They're usually trained on one specific robot embodiment with one specific arm length and joint configuration, and they don't generalize cleanly to anything else. Lingbot VLA 2.0 solves this along 3 specific axes. First, morphological generalization. The public model is a 6 billion parameter checkpoint built on Qwen 3, I instruct that works across a wide range of robot body types, not just the training platform. Second, an expanded action space. It now handles higher DOF configurations, full arm mobility, and mobile manipulation on wheeled bases, not just static tabletop manipulation. And third, predictive dynamics modeling. 2 teacher models supervise training through distillation. Lingbot Depth, which supplies geometric cues via depth prediction, and Dino Video, which was trained on 5 million video clips spanning internet, egocentric, and robotic data, and provides temporally grounded semantic context. Now, for the benchmark numbers. On GM100, which is the Great March 100 bimanual manipulation benchmark from Shanghai Jiao Tong University, a single joint policy trained on 9 tasks per embodiment shows a progress score of 66.2 and a success rate of 34.4 on the AgileX Cobot Magic platform. That's up from 58.2 and 30.0 for Lingbot VLA 1.0 at 36.3 and 17.8. On the Galaxia R1 Pro platform, it scores 34.6 progress and 15.6 success rate, up from 32.7 and 15.6 for VLA 1.0. Now, here's a detail that I find particularly impressive. One inference call takes about 130 milliseconds on an NVIDIA GeForce RTX 4090D. That's actually fast enough for real-time robot control on a consumer GPU, which is pretty wild for a 6 billion parameter VLA model. It's already being deployed in real-world commercial pilots with partners like Liju and T5 Robot, in retail sorting at Guoda Drugstore, and in industrial automation at Longsheng Technology. The awesome thing is they've released this already under Apache 2.0. The 6B checkpoint, the code base, and the technical report are all on Hugging Face and GitHub. If you're interested in reading further, I'll link to this page in the description below. Next up, NVIDIA releases a pretty fascinating new open source audio model. It's called Nemotron Labs Audex 2B, and this is a unified 2 billion parameter model that does 6 completely different audio tasks in a single architecture. In other words, you don't need 6 separate models for audio understanding: speech recognition, speech translation, text-to-speech, text-to-audio generation, and speech-to-speech. Audex 2B does all of them. Now, you see, the typical problem with adding audio capabilities to a language model is regression. Every time you teach a model to handle audio, you usually trade away some of its text reasoning ability to do it. Audex 2B's training pipeline, which uses multi-stage SFT followed by cascaded RL, is specifically designed to preserve the full text capability of its backbone alongside all the audio capabilities. It operates in both thinking and instruct modes, supports a 128K context window, and follows Nemotron Cascade 2's text performance on the text evaluation suite. Now, can you run this on a consumer GPU? At 2 billion parameters, yes, absolutely. The model supports VLLM and Hugging Face Transformers inference. It needs Transformers version 4.53, 0 or higher. And there's a small VLLM plugin to install for audio tasks, but beyond that, the setup is straightforward. Now, I'll note the license. Audex 2B uses the NVIDIA one-way non-commercial license, which means it's free for research use, but not for commercial deployment without a separate arrangement with NVIDIA. If you're interested in reading further, I'll link to this page in the description below. Also, this week, OpenMOSS releases a really useful new open source transcription model. It's called MOSS Transcribe Diarize, and this is a 0.9 billion parameter model that can take up to 90 minutes of any multi-speaker audio and produce a fully timestamped, speaker-attributed transcript in a single inference pass. Now, you see, the traditional approach to speaker-attributed transcription is a pipeline. You run ASR to get text, then you run a separate diarization system to figure out who said what. Then you try to align the two outputs, and every handoff between systems introduces errors. MOSS Transcribe Diarize does all of this in one shot, jointly, using a single end-to-end multimodal architecture with a 128K context window. For your reference, here are the benchmark numbers. On the podcast dataset, which is a long-form multi-speaker benchmark, MOSS Transcribe Diarize achieves a character-level error rate of just 6.97% with a speaker attribution error of 2.50%. And it outperforms every commercial system it was compared against, including Dubao Speech Recognition, 11 Labs Scribe V1, GPT-4 O Transcribe Diarize, Gemini 2.5 Pro, and Gemini 3 Pro across 3 representative benchmarks covering long-form meetings, extended multi-speaker conversations on podcast, and short overlap-rich segments on movies. Now, can you run this locally? Yes. It's a 0.9 billion parameter model, which means it runs on basically any GPU you have, and there's a free demo on Hugging Face Spaces you can try right now without downloading anything. The awesome thing is they've released this already today under Apache 2.0. The weights and code are on Hugging Face and GitHub. If you're interested in reading further, I'll link to this page in the description below. Also, this week, the WAN team at Alibaba releases a significant upgrade. It's called WAN Streamer V0.2, and this is a resolution upgrade to the real-time audio-visual interaction model I covered a few weeks ago. Now, if you remember, WAN Streamer V0.1 was already remarkable. A single end-to-end transformer that could listen, think, speak, and respond with a synchronized face and video, all at around 200 milliseconds of model-side latency. The problem was that V0.1 ran at 192 by 336 pixels, which basically looked like a video call from 2007. WAN Streamer V0.2 bumps that output resolution from 192p all the way up to 640 by 368, which is a 3.3 times increase in pixel count. And critically, the 200 millisecond model-side latency stays completely unchanged. Total end-to-end latency also stays at around 550 milliseconds, including 350 milliseconds of network time. Now, how they achieve this without adding latency is actually the interesting engineering story. The key is a new thinker-performer architecture. The thinker stays on a single GPU and handles perception, language, and state updates, KV construction, and decoding. The performer is a separate multi-GPU group that runs Ulysses-style context parallel denoising for the higher resolution video latents. The two pipeline in parallel across 160 millisecond streaming units, so the extra GPU compute for the higher resolution never actually adds to the latency budget. It also expands the visual format from close-up video call framing to scene-grounded mid-shot agents, meaning you can now see the agent's full upper body in context, not just a face close-up. The paper is on Arxiev. Code is not yet public, but expected to follow. If you're interested in reading further, I'll link to this page in the description below. Also, this week, ByteDance officially launches their flagship image model. It's called Seedream 5.0 Pro, and this is ByteDance's most direct challenge yet to GPT Image 2. Now, the 4 headline capabilities are these. First, complex information visualization. The model can take a detailed text prompt describing a dense infographic, poster, or UI layout, and generate a well-structured, information-accurate visual in a single pass. It natively handles high-density text, data charts, flowcharts, and multi-section layouts. Second, interactive precision editing. You can use point selection, lasso selection, sketch guidance, or annotations to specify exactly what you want to change. The model modifies that one element while preserving the lighting, textures, shadows, and composition everywhere else. And critically, it also generates up to 10 separable layers as output, so you can export the result directly into a design workflow and edit individual elements independently. Third, cinematic visual quality. It specifically targets photographic lighting, material behavior, and human skin texture at a level designed to hold up as keyframes for video generation. ByteDance explicitly positions this as the image model that feeds Seedream 2.5 when you want clean, cinematically consistent base frames. And fourth, native multilingual text rendering across 14 languages, including Arabic with proper right-to-left layout, Japanese, Korean, Russian, and more. Now, for pricing. On the API, it runs from about $0.032 per image at lower resolutions up to around 9 cents at full 2K output. Maximum output resolution is 2048 by 2048. For context, that puts it well below GPT Image 2's high-quality pricing tier. Now, I'll be upfront that ByteDance did not publish any formal benchmark numbers at launch. No Gen Evil, no DPG bench, no head-to-head arena scores. So all the capability claims above are ByteDance's own positioning. Independent evaluation hasn't happened yet. Seedream 5.0 Pro is live now on Dreamina, on the Volcano engine and BytePlus APIs, and on FAL.ai and Magnific. If you're interested in reading further, I'll link to this page in the description below. Also, this week, Reve releases a pretty impressive update to their image model. It's called Reve 2.1, and if you're not familiar with Reve, this is a Palo Alto startup of around 65 people that's been quietly building one of the best image models in the world. Their whole approach is fundamentally different from every other image model out there. Instead of going straight from your text prompt to pixels, Reve first builds what they call a layout. Think of it as like HTML for an image. Every element in the scene gets its own position, size, and description before a single pixel is rendered. So when you want to change one thing, you change that one element in the layout and re-render. The rest of the image stays exactly as it was. That's why they describe it as images you can touch. Now, Reve 2.1 is a noticeable upgrade over 2.0, which only launched a month ago. 3 specific improvements. Better prompt understanding, so it follows complex instructions more accurately. Sharper image quality with more detailed and precise results, and much stronger text rendering inside images, even in non-Latin scripts and foreign languages. Now, the reason that last one matters is that in-image text has historically been the clearest tell that something is AI generated. Warped signs, garbled labels, menu text that dissolves into random characters. Reve has been specifically targeting this, and 2.1 is another meaningful step forward on it. Now, for the benchmark numbers. Reve 2.1 has landed at number 2 on the text-to-image arena, scoring 1,306, which is 28 points ahead of the next best model. That's also a 36-point jump over Reve 2.0 in just 1 month. And it ranks in the top 3 across 6 separate categories, including product and branding and cartoon. The part worth sitting with is the resource story. This is a 65-person team competing directly with OpenAI and Google for the number 1 and 2 spots on the same leaderboard. And according to their own team, this latest training run used more compute than before through something they call async DP, a cross-cluster distributed algorithm they built themselves, all without going beyond their existing hardware provision. In other words, they're not outspending anyone. They're out-engineering them. Reve 2.1 is live right now at app.reve.com. It's a closed model, no open weights, available through their web app and API. If you're interested in reading further, I'll link to this page in the description below. And finally this week, we have a really cool new open source world model. It's called Alaya World, and this generates interactive, playable video worlds with real-time camera control that you can navigate using a joystick at 720p and 24 frames per second. Now, this is genuinely different from just generating a video clip. The key thing about Alaya World is that you can actually move through the world in real time. And when you turn around and look back at where you came from, the scene stays consistent with what you saw before. That consistency under revisitation is actually one of the hardest unsolved problems in world models right now. So how this works is the model uses a dual memory system, an explicit 3D cache that gets reprojected to whatever view you're currently looking at for spatial recall, and a compressed frame history embedding for temporal continuity. The camera control is a 6 degrees of freedom joystick using Adelan modulation, and the model runs a few-step DMD distillation for real-time speed without sacrificing generation quality. And there's a second control channel worth highlighting. You can drop a text prompt mid-generation to trigger an event inside the scene. You're exploring a misty Chinese water town, and you type "fireworks burst over the rooftops." The fireworks happen. You type "a giant tree crashes from the sky," and that happens too, all while the camera keeps moving and the rest of the world stays consistent. Now, the demos also include generating the same scene across 7 different visual styles simultaneously, from realistic to Minecraft to cyberpunk, and game world generation in styles that closely match Genshin Impact, Cyberpunk 2077, Elden Ring, and Red Dead Redemption. In their consistency comparison against competing methods including Dreams World, Lingbot Fast, and HY World 1.5, Alaya World shows significantly better spatial consistency when the camera turns and revisits a location. It's a 15 billion parameter model, runs at 720p and 24 FPS in real time. The awesome thing is they've released this already. The code is on GitHub and the paper is on RxIve. The team is from ALA Lab, a research group linked to Shanda Group. If you're interested in reading further, I'll link to this page in the description below. And that sums up all the highlights in AI this week. Let me know in the comments what you think of all of this. Which piece of news was your favorite? And which tool are you most looking forward to trying out? As always, I will be on the lookout for the top AI news and tools to share with you. So, if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So, to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.